Good morning, everyone. Today we're going to be talking about the Neo4j graph database and graph platform. We'll be talking about what a graph database is, when you might think about using one, how graph databases differ from other database technologies that you may be familiar with, and some of the add-on tools and technologies that we are bringing to market to enhance the Neo4j platform. So why are we here? So like many database vendors and big data vendors, we point to the fact that data is growing at an exponential rate. There's more data coming to us every day. It's coming through a variety of new and innovative channels, and it has to be managed and exploited. Where Neo4j and other graph technology vendors differ perhaps from the traditional mainstream of database technology and some of the big data vendors is that we also point to the fact that the data is becoming increasingly more connected. People, processes, assets, and devices. And our customers have found that there is real value in the relationships between data, and that a technology like a graph database can allow you to unlock the business value that is tied up in those relationships and exploit them to develop new capabilities for the business. And this has been highlighted in a number of analyst reports. So what do we mean by connected data? Well, it comes down to networks typically. For example, you may have networks of people, you may be interested in organizational structures, you may be interested in supply chain, you may be interested in understanding how partners and suppliers relate one to another, and how customers take advantage of a particular service. Increasingly, our customers are using Neo4j also to model their internal business processes. So they're needing to understand the dependencies between different parts of the business, between different activities. And that ties into things like risk management and supply chain, increasingly as well, payments and fraud detection. And then on the right there, you have knowledge networks. So this is essentially being able to unlock the knowledge that's available across the business that may be tied up in different data silos. Things like knowledge graphs, things like understanding how your digital content is being used and how it can be made more available to people. A whole range of different data that needs to be brought together, and where the connections between the data can be as important as the data itself. So what we'll show today is that a graph database like Neo4j is a uniquely powerful way of tying all this data together and taking advantage of it in a way that traditionally has been a challenge. And why do we say that? Well, I think for many of our customers, they find themselves at a crossroads. They have a long-standing investment, particularly in traditional relational database technology, but increasingly they are looking at more diversity of data and thinking about the best way to handle that. And so for many of them, they're looking really at this crossroads, this turn left or turn right. Turn left towards denormalizing data, storing it in documents, for example, aggregating data together, and that has many advantages. It's a great way of handling unstructured data, for example. Or the alternative is turn right. Look at the complexity, take advantage of the complexity that's there, capture it in its fullness, and use something like a graph database, essentially to join all the data together, to understand better how it's all joined together and take advantage of these connections. So really, you can think, one way of thinking about this crossroads is that you've got the choice between something which is collections focused on the left. These are your relational databases, your other NoSQL databases, document databases, key value stores, etc. These have a variety of different formats, but they're very much focused on how you collect and aggregate data together. On the right, you've got something like a graph database like Neo4j, and this is more focused on the connections rather than the collections of data. So it's very much focused on the relationships between data. And there are a number of benefits that come from this approach, including the fact that it's easy to capture and model the complexity of interconnected data using something like a graph database. There's a very powerful query mechanism with Neo4j, which allows you to write very succinct and very expressive graph-oriented queries. And for a lot of our customers as well, there's the practical benefit that you are typically able to query very complex and interconnected data in a much more scalable way and on much less hardware than might be required, particularly with something like a relational database, like Oracle or MySQL or DB2. So what does all that mean? Well, if you think about how data management projects typically start, they often start by going to a whiteboard and drawing something like an entity relationship diagram or a data diagram. And one way to think about a graph database like Neo4j is that it captures that whiteboard model of data types and their connections with very high fidelity. So you can think of it as your whiteboard model is essentially your database schema. You're not required to go and think about denormalizing the data, how you would effectively store it in something like a relational database. You can really capture that whiteboard model of data very directly. So we'll show you how that manifests itself in a few slides' time. So Neo4j then, at its core, it's a graph database. It's a database that stores both data and the relationships between data as equivalent first-class objects. And increasingly, Neo4j is also a graph platform. So it has a number of extensions to allow you to use different development tools, different programming languages. There are a variety of ways of presenting information in both graph and tabular ways. There are integrations with other analytics tools and a variety of ways of ingesting data from different sources. So really it's about being able to store, reveal, and query data in all of its complexity. It's being able to explore that data, even very large data sets in real time. And it's about being able to layer in new context, new data sets, new data dynamically on the fly, as we say. So you can take an existing deployment, an existing data model, and you can add additional data sets to your graph without the requirement to take the system down and rebuild the schema to accommodate the new data sets. So in that sense, it's a very adaptive and evolving technology. It allows you really to start small and then grow out very easily. It's also a fully fledged database management system. It has all of the functionality that you'd expect from a database. And we'll talk about some of those features again in a few slides' time. Under the covers, Neo4j is based on what's called the labeled property graph model. So this is a model of graphs which essentially has two important components, and these are nodes and relationships. The nodes on this diagram are shown as in circles, and the relationships are shown as arrows. So in this particular simple schema, we've got a person type and a car type. You'll note that the person type has a set of properties, the name, date of birth, Twitter handle, for example. And indeed, the relationships also have a set of properties. So with a graph database, it's perfectly possible to query the data, obviously, very simply, but also the relationships between data. Properties are stored as name-value pairs, so it's a simple, very extensible model. And you can put indexes both on data types and on the relationship types. Note that you have the full expressivity of a graph model here. So you can model arbitrary relationships between different data types. It's a very schema loose or schema free model. You can create relationships between different data types as required. And you can also use the power of the graph engine to uncover implicit relationships or relationships between different parts in the graph which don't have a direct connection. So it's a very powerful way of exploring and understanding how data is connected together and finding the connections between data. Neo4j comes with a query language called Cypher. It's a graph-oriented query language, somewhat loosely based on SQL, but with graph concepts rather than tabular concepts. So at the bottom there, you've got possibly the simplest kind of query. This is a match query. So this is somewhat like the select statement in SQL. And here we're looking in the database for a person with the property of the name Dan, who has a relationship to another person, and that relationship is of type married to. And this simple query will find us the name of the person who Dan is married to. So notice that this is it's a very novel and a very clear way of expressing a graph query. It's actually based on ASCII art. So if you notice, data nodes are circles in the diagram, and relationships are arrows. And we've captured that kind of graphical view of the world in the query language. So data nodes here are represented in round brackets, and the relationship type then is modeled as an arrow relationship. So it's a very intuitive, very quick to pick up kind of query language, and also very expressive. You can often write the equivalent of hundreds of lines of SQL code in a very few lines of Cypher. So that's a very quick whistle-stop tour of what the technology looks like. In terms of where it's being used, it's an uncontroversial choice. It's a kind of technology that is used across many industries, and there's a selection here of some of our customers, both large and small. You'll see there are platform vendors there like LinkedIn, which uses Neo4j actually to gamify parts of its platform for some of its markets in the Far East. We have customers like eBay who've developed chatbot, shopbot technology using Neo4j. We've major financial organizations like UBS and Nomura who use Neo4j for a variety of purposes. So it's a technology that has established itself as a significant choice. It's part of the emerging movement of what we call polyglot persistence. So this is the idea that increasingly developers can use a variety of different database technologies in their projects, and they can pick and choose and mix and match different database technologies according to need. So it's not at all uncommon for a large customer of Neo4j to have an Oracle backend, a document store like MongoDB, possibly something like Elasticsearch, and Neo4j, all being used as part of the same platform. And essentially you're using the different technologies to do what they're best at, which in Neo4j's case is to handle complex interconnected data where you're particularly interested in how things are related to each other. In terms of some of the more high-profile use cases you may have seen, of course, the Panama Papers and the Paradise Papers, which were journalists-led exposés of offshore bank accounts, that was all powered by Neo4j. On the left there, you've got NASA, which has built a lessons learned knowledge graph on Neo4j. So essentially it's tying together more than 70 years of rocket program data using a graph model to link it all together and enable its scientists and researchers to be more effective. On the lower left there, you've got the DZD in Germany, which is making powerful inroads in the fight against diabetes, again using Neo4j to link together research data and make it more explorable in a way that hasn't been possible before. This is a very brief snapshot of some of the more common use cases that we see. You'll notice that the common theme is that you've got a lot of data and that the data itself is highly interconnected. So you have things like real-time retail recommendations. On the left there, you've got fraud detection in the banking and insurance markets. There are numbers of master data management applications for things like data governance, data lineage, data quality. And also there on the right, you've got a variety of identity and access management, where you use the power of the graph to manage complex interdependencies of who should have access to particular data based on who they are, where they are, the time of the day, the particular laws that apply, etc., etc. Something that's quite easy to model in a graph database. In terms of the life cycle, what we typically find with our customers is that they often start small. They take a problem of interconnected data in a single domain. That's your first graph there on the left, and they use the power of the graph to link it together, often just to visualize it and understand better how things are connected to one another. As time goes on, you can develop this, you can add more data to develop a context for particular data, and use that context then again to better understand how things are connected, and possibly to model, do what-if analysis, model the future. The progression then typically is bringing in additional data sets from often different data sets and linking them together using the power of the graph database to understand how dependencies emerge. And increasingly over time, you can build up what's called a layered graph. So you can bring new data sets in, you can layer them into an existing graph model, and you can write systems in such a way that your existing queries can take advantage of this new data as it becomes available. And in the most advanced cases there on the right hand side, you've got advanced machine learning, AI based systems. So here the graph is essentially learning as it goes along. So it's perfectly possible to build systems where as you traverse paths through the graph, you can put weightings on them to make them more likely to be picked up in searches in the future. And this allows you to develop quite powerful neural network type applications where the graph essentially evolves and adapts as it goes along. I said earlier, Neo4j is increasingly becoming a platform. So there is a full range of tools and technology out of the box to help you integrate it into an existing system, to make it live happily alongside existing legacy data stores and other database management systems, and a variety of algorithms and tools to allow teams like data scientists, for example, to be able to build out and take full advantage of the graph model. I said that Neo4j is a fully fledged database management system, so it has all of the functionality you'd expect if you were buying a database. Number one there is index-free adjacency, and this is a very powerful feature in what are called native graph stores like Neo4j, which allows you to have very fast traversal times, very fast access times to data, but above all, very consistent access times to data. So in Neo4j, it doesn't matter whether you have 1,000 nodes in your graph or 1,000 million nodes in your graph, the query times will be the same. It's an ACID system, so it's fully transactional. You're sure when you write data out that it is written out and the database is never left in an inconsistent state. And point 3 there, it's a clustered system. So you can cluster Neo4j for both high availability and for read scalability. It's a full set of language drivers and tooling, and a number of enhancements in the platform to make sure that the system executes queries in an intelligent and resource aware sort of a way, and gives you all of the tooling that you would require to be able to understand where performance is at a premium. I said earlier, Neo4j is a native graph database. So what does this mean? This means that in one sense that it's graphs all the way down. It's graphs on the screen, it's graphs in memory, it's graphs all the way to the disk. And this is it's very powerful, it's a very necessary feature of what we call a native graph store. So it generates a number of performance benefits, particularly for consistency of performance. It ensures that your hops, your traversals around the graph, again, are of a consistent nature. You don't find that the first 3 hops, for example, around the graph execute in a very small window of time, but the 4th hop is 10,000 times slower because it happened across a boundary in the underlying database management system or across a cluster. And it also allows us to, it gives a number of benefits in terms of the purity and the consistency of the interfaces that we can provide. Out of the box, Neo4j comes with a range of algorithms, data science and graph-oriented algorithms. So these arise out of graph theory, but allow you very powerfully to understand, for example, to identify whether on communities within the graph, to find the optimal path between points in the graph that may not be directly connected. Implementations of things like PageRank, for example, available out of the box. So it really is, it's a very productive environment. You can get started very quickly with Neo4j and build quite powerful systems very quickly. Bloom is a relatively new addition to the Neo4j platform. It's a user interface and data exploration tool. It provides a very modern looking and very scalable front end to graph applications, and it is oriented to both technical users and non-technical users. It allows you to visualize very large graphs and to do that in a way that is very intuitive and allows visual examination and exploration of the graph. It has a non-Cypher search capability, so it allows you in natural language to do quite complex navigation around the graph. You can start typing a particular data type and it will prompt you for connected nodes between these, and it will allow you then to explore the graph very quickly without having to learn Cypher. It also allows you to embed business logic behind push buttons, such that you could put it in front of a non-technical user and embed quite a lot of business logic behind, in fact, to hide the complexity of that behind push buttons on the screen. It's available for trial and exploration. If you want to contact your local Neo4j representative, then you'd be very welcome to try Neo4j Blue. Finally, as well, we've also brought together a new data integration tool called Morpheus. This is it's a hybrid workbench that allows you to link the database into graph processing technologies such as Spark, and also allows you easily to move data between things like Hadoop and the graph world. So it allows you, on the left there, as I say, to take data from HDFS and from Hive, to impose or infer a graph model on it, to do complex graph processing in something like Spark, and then to store the results safely and securely back into the graph database, Neo4j. So it really does expand the world. It brings the whole graph ecosystem together and allows the worlds of big data and connected data to work in a much more effective way. And one of the reasons it does this, so one of the powerful mechanisms by which it does this, is that it allows you to return data results as a graph. So you can now pass subsets of graphs between different platforms more easily without having to translate them into tables or other data types. So really, again, allows you to take full advantage of the power of the graph model and share that power between different platforms and environments. For time, I'll quickly move on to answer a question which we're often answered, which is, does Neo4j scale? And we can point to a number of our large customers around the world who are using it for 24/7 mission critical deployments where speed is of the essence. So we have customers like Marriott, for example, who built a real-time pricing engine for its hotel properties in North America, and this has up to 300 million pricing operations running through the system every day. We have large customers in the logistics and postal arena who use Neo4j to manage countrywide networks of postal systems and make sure that parcels get delivered to their intended addressees consistently, allows them to restructure their networks in real time to redirect flows of traffic around hotspots, etc. And then on the left there, real-time recommendations, large retailers who are dependent on Neo4j to ensure that their customers get highly personal, highly tailored recommendations in real time at the checkout. So all of these speak to the fact that the Neo4j is a technology that can start small and can scale up to even the largest workloads. So that's really it. It's a very whistle-stop tour, I appreciate. We'll take some time here for questions.
Great, thank you so much, Anthony. Just a reminder to everybody, just in the remaining time, if you have any questions, just type those out in the questions box on your GoToWebinar control panel. So to start us off, I think you'd mentioned that Neo4j has a really flexible data model. So are there kind of any tools or frameworks in place for building a UI that would allow you to edit flexible data in the graph? Or how would you go about editing things like that?
We have Joe on the line. So Joe, I think that's a question best answered from the field.
Sure. So Anthony, you talked before a little bit about Bloom, which is our new visualization and data exploration tool. Bloom does come with some data entry functionality. So you're able to edit the properties that exist on nodes. You're able to create new nodes, duplicate nodes, create relationships between nodes. So that's quite a useful feature. It's not so good for creating a large graph from scratch visually. You're best doing that, from a data import, CSV, or coming from an existing database or something like that. But for minor edits, keeping data up to date, adding new bits of data manually as they come in, that's quite useful. It is also possible to write custom front ends for Neo4j. So a lot of times people will embed Neo4j into an existing presentation layer. You can do that with a number of JavaScript frameworks. We work quite a bit with what we call the Grand Stack, which is GraphQL, React, Apollo, and the Neo4j database. And you see front ends, also visualizations and things like that being made with, Node.js or D3 for graph visualization and things like that. So yeah, there are a number of ways of creating front ends for managing the graph and editing the graph, either Bloom or custom. But again, you probably wouldn't want to create a huge graph manually in this way, right? Mostly this will be for small edits, manual updates, and keeping data up to date as you work with it.
Great, thank you. So another quick question, if you're already using a relational database, as many people are, is there kind of a process to migrate that data into Neo4j, or what would that look like?
Okay, so the Neo4j can integrate directly with relational databases. So we do ship a number of tools for kind of point-to-point integration, reading data out of relational databases into Neo4j. You can also use ETL tools. So we do a lot of work with Kettle, which is the open source ETL tool that underlies Pentahost data integration. Also with Talend, Informatica, these sorts of tools for pulling data out of a relational database into Neo4j. And we do have in beta right now a more visual ETL tool as well that will connect to your relational database, read the schema, present that to you in a window, and allow you to then map which elements of your relational database will become elements of your graph. So what becomes a node, what becomes a relationship, what becomes properties, and then help you with that import. So there are a number of ways of doing it. It depends on whether you have ETL tooling in place already, how comfortable you are with kind of just direct integration and mapping, or whether you want a more visual tool.
Thank you very much, Joe. We're just about on time, so I'll just finish up by saying that we're happy to provide a variety of resources to help you get started if you want to look at Neo4j. There's quite an extensive schedule of things like webinars and public training classes and conferences which we run around the world. You're welcome to attend any of those. There's also quite an extensive what we call a Graph Academy. So this is a one-stop shop for things like training, how-to guides, videos, best practice, etc. And then the last thing to say is just that we are very happy and very keen to help. If you've got a particular project where you think a graph database like Neo4j might be a good fit, then please do reach out to us. We have representatives around the world. We also have a field consulting team, which is available to help with things like proofs of concept or evaluations. They're very skilled in best practice around data modeling, implementation of queries, data ingest, visualization of data, and how you would deploy a Neo4j system to be scalable and highly available. So do feel free to reach out to us. My email address is there on the screen, or you can find your local representative on our neo4j.com website under Contact Us. Thank you very much for your time today. I hope it's been useful. We'll look forward to speaking to you on the next Neo4j webinar.